What's up guys, welcome back to the channel. Today in this video we'll be doing Cramer's rule for 3 by 3 matrix. So we're going to be using Cramer's rule to actually solve for x, y and z. So before we start though, you can pause this video. If you know how to solve for unknown using Cramer's rule, you can pause this video, try to solve and find your unknowns, and let's see if your answers are going to be the same as the one that we're going to get at the end of this video. All right guys, so before I start solving this, I just like to say thank you very much guys for watching, subscribing to the channel, commenting, and not forgetting those who like and share the videos. If you haven't subscribed to the channel, subscribe to the channel because we've made lots and lots of videos on this channel concerning mathematics. You can also support our channel by hitting the super thanks button. But if you can't, a like, a comment, a share, and also a subscription will be highly appreciated. Now let's get back to our problem then. As you can see here, they want us to solve for x, y, and z. So these x, y, and z, we do have them on these equations that you see here. We have equation 1, equation 2, and equation 3. Now, how are we going to calculate our determinant? First of all, we need to create the square matrix. So when you create the square matrix, let me just do this. You have to take the coefficient of each and every unknown here and create the row or the column. So we're gonna create the square matrix. So each and every equation here represent the row. So let's look at the first equation there. The coefficient of x is 2, so it's going to be our first entry on the square matrix. Now the coefficient of y is positive 1, so it's going to be our second entry on our square matrix. The coefficient of z is negative 3. There we go. As you can see, 2, 1 and negative 3, they are from equation 1. Right, now we move to equation 2. Equation 2 represents the second row. The coefficient of x is 1, the coefficient of y is negative 2, the coefficient of z is 2. There we go. And then the last equation, which represents the last row, we're going to take the coefficient of x, y, and z as well here. So the coefficient of x for this one is 1, the coefficient of y is negative 1, and then the coefficient of z is going to be positive 2. There we go. So this is how you create the square matrix when you're given equations like this. But you're not done. The cofactor signs. So we start with positive, negative, positive, negative, positive, negative, positive, negative, positive. Right. So as you can see, these signs here, they actually alternate. So do not forget, guys, we're going to use them to calculate our determinants. The last step left for us to do before we do the calculations of determinant, we need to select a row or a column. So I prefer to select a row, which makes it easier for me, especially the first row, guys, makes my life easier when I do some calculations. So as you can see there, I've selected the first row. Now it's time for us to calculate our determinant. All right, so let's calculate our determinant here, guys. Remember, we're gonna have to take these entries that we selected on this row as our reference to calculate our determinant. We can say cofactor 2. Basically, what we are saying here is we're gonna calculate the cofactor of 2. So what we're going to do when you calculate the cofactor of 2, we have to cancel the row and the column where 2 is part of. Right, now that we have done that, it's time for us to look for the cofactor sign. So as you can see, 2 is our first entry there. When you look at the cofactor sign, the sign here is going to be positive. So it means that our 2 here is going to be positive. But what is it that we are left with here on our square matrix? We are left with this square matrix here. We call it a minor, which is going to be negative 2, 2, negative 1, and 2. So this here is our minor. Now that we are done with the first one, now let's do when our cofactor is 1. There we go. Let's first cancel the row and the column where 1 is part of. So let's do it. Now let's look at the sign where 1 is. Remember, 1 is our second entry there. And when you look at the signs here, our second entry is going to be negative. So we can say negative, and then we write 1 there. Right. So what is it that we're left with here? Our minor here is going to be 1, 2, 1, 2. There we go. So it's going to be 1, 2, 1, 2. So this is our minor. Now that we are done with this one here, let's do the last one. So the cofactor, negative 3. Before we do some calculations, we need to cancel the row and the column where negative 3 is. So as you can see here, we are canceling. We'll be left with the following here. Now let's look at the sign. Now the sign here is positive because our -3 is there. All right, so let's do it. We're gonna say plus because our sign is positive there, but let's not forget that our 3 is negative. There we go. And then from there we multiply by our minor. What is it that we're left with there? We're left with 1, -2, 1, -1. There we go. This step here is very necessary, guys, for you to calculate the determinant. So let's do the following step. We'll have to calculate the determinant of these square matrix that you see here. So we have to keep the 2 here for the first one, and then we calculate the determinant of the square matrix. We know that we have to multiply the first entry and the last entry of the square matrix. So it's going to be -2 multiplied by 2 minus. So this is going to be minus by the product of the second entry and the third entry. So it's going to be 2 multiplied by -1. There we go. So we are done with the first one here. Now we move to the second one. Now when we move to the second one, let's not forget we have negative here. We have -1. Then we calculate our determinant. So when we calculate our determinant, remember, first entry multiplied by the last entry, which is 1 multiplied by 2, minus the product of second entry and the third entry, which is going to be 2 multiplied by 1. There we go. So we are done with the second one. Now let's do the last one. Now let us not forget that we have plus and -3 there. This is going to give us -3. And then let's calculate our determinant. So we're going to multiply the first entry with the last entry, which is going to be 1 multiplied by -1 minus the product of the second entry and the third entry, which is going to be -2 multiplied by 1. There we go. So we are done with this step here. So let's do the next step. We're going to put all this on our calculator, and then we're going to get -4. On the next one here, we're going to put this on our calculator, and this is going to give us -0. And the last one here, we're going to put it on a calculator, and that is going to give us -3. Now our determinant for this square matrix that we just created is going to be -7. There we go. So this determinant, we're going to use it, guys, to calculate the unknowns. Remember, we have to calculate for x, y, and z. Now in order for us to calculate this unknown, we need to calculate their determinant. So we're going to calculate the determinant of x, which is dx. All right, guys, so let's create space so that we can calculate our determinant for x. So before we calculate dx, we need to go back to our question and also our original square matrix there. So I'm going to erase all these things that you see here so that it doesn't disturb us. Let's look at our original square matrix here. The first column is for x, guys, just in case you didn't know. The second column is for y, and the last column is for z. As you can see, our equations here, they are aligned in that manner. Our first term is x, our second term is y, and the third term is for z. Since we will be calculating the determinant of x, we're gonna substitute these entries of x with the entries of constant there. So basically what we're going to do, we're going to rewrite our square matrix with the entries of constant on the first column. So we know that dx is going to be equal to, on the first column, we're going to put the entries of the constant, which is 3, 0, and 2. But we're going to keep the ones for y and z, which is 1, -2, -1 for y, and for z is -3, 2, and 2. There we go. So this here, guys, it's our new square matrix for dx. We're gonna do a similar what we did when we calculate this determinant here. Now we're still gonna use the cofactor expansion. So we're gonna use these signs here, just like the previous one there. Remember, the signs, they alternate, guys, right? It's plus, minus, plus, minus, plus, minus. Now that we are done with cofactor sign, it's time for us to select the row or the column. I'd rather select the column this time so that I can show you guys. It doesn't matter whether you select column or a row, just select at least one. I prefer to select the first column or the first row, but it's really up to you guys. Which one do you wanna use when you calculate your determinant? All right, now that we've selected our row, let's find the dx. Now we can say cofactor of 3. Let us not forget now that we selected the row, so we are moving downwards like that. So when we say the cofactor of 3, it means that we have to cancel the row and the column where 3 is part of. So we cancel row, and then we're going to cancel the column, right? As you can see, 3 is our first entry, and the sign that correlates with 3 is there. So it's going to be positive. So meaning 3 is going to be positive. What about our minor? What is it that we're left with there? We're left with -2, 2, -1, 2. There we go. So this is what we're left with. Now let's move to our cofactor when it's 0. We have to cancel the row and the column where 0 is. So let's do it. Now let's look at the cofactor sign that correlates with 0. Now if you can see here, this sign is negative because our 0 is there. Let's put negative there. So multiply by 0. So what is it that we are left with here? We'll be left with 1 minus 3 minus 1 and 2. So this is our minor when we are calculating for the cofactor of 0. Now that we are done with this one, let's do the last one then. Cofactor 2. So meaning now we have to cancel the row and the column where 2 is part of. Guys, do not forget we are moving with the column that we selected. Now let's look at the sign that correlates with the 2 there. The sign here is going to be positive and our 2 is also positive. So it means this is going to be plus. Then we say 2 there, and then we have to write our minor. Our minor is what we're left with there. It's going to be 1, -3, -2, 2. There we go. Now the next step here, guys, it will require us to calculate the determinant of these minors here. Let us not forget that we have 3 here on the first one. Now it's time for us to calculate the determinant of this. Remember, is the first entry multiplied by the last entry minus by the product of the second entry multiplied by the third entry. There we go. Now let's do the other one. Let's not forget that we have minus here multiplied by 0. Now the determinant, again, first entry multiplied by the last entry, 2 multiplied by 1 minus by the product of the second entry and the third entry, which is going to be -3 multiplied by -1. There we go, these two here. Now let's do the last one. As you can see, we have plus here 2. Now let's calculate the determinant of this square matrix here. Now it's the first entry multiplied by the last entry, which is 2 multiplied by 1 minus by the product of the second entry and the third entry, which is going to be -3 multiplied by -2. There we go. So this is what we have. Let me just create a barrier here, guys. Now on this following step here, we're going to put this on a calculator, which is going to give us -6. Now if you put this on a calculator, everything is multiplied by 0 there, as you can see there. So this one here is going to give us -0. Now the last one here, if you put it on a calculator, it's going to give us -8. So our dx, when you add these numbers together, it's going to give us -14. So this is going to be our determinant for x. Just in case you don't know how this thing came about, how we calculated all these things, I will leave a link on the description that contains the determinant videos that explain almost everything that we have here. So go to that link and watch those videos. And also that playlist will pop up on the top right of this video. Click on it, watch, so that you can able to understand all the steps that we use here to calculate the determinant. All right, guys, now that we are done with dx, so I'm going to erase the calculations of dx here so we can able to do dy. Before we continue, let me first write the value of dx here so that we don't forget. Remember, dx we got -14. Now that we are calculating dy, we need to do what we did when we calculated dx. Again, we're going to take this constant here that you see here, and then we're going to substitute from our original square matrix on the second column, because the second column, as you can see here, is for y. Now let's recreate the square matrix here on our left. Dy is going to be equaling to, now the first column, because it's for x, it's going to remain what it was from the origin. It's going to be 1, 1, 1. We're no longer calculating for x. Now for the second column, because the second column is for y, we're going to put the constant. Now it's going to be 3, 0, 2. There we go. And the last column is for z. We're going to rewrite it just like the original there. We have -3, we have 2 there. When you calculate the dy, we're going to use the cofactor expansion method. So we have to do the cofactor signs. Remember, the signs, they alternate, guys, right? Remember, the signs, they alternate. There we go. So after here, guys, we also need to select whether a column or a row. So this time around, let me just select the first row. There we go. All right, guys, so when you continue here, let's not forget that we're going to use the entries that we selected on this row as our reference. So we can say cofactor 2. We have to cancel the row and the column that 2 is part of. So let's do it. So let's cancel the row here and this column there. So let's look at the sign where 2 is. Remember, 2 is our first entry there. and our sign here is going to be positive. All right, so we're going to write 2 here. Now, what is our minor that we'll be left with here? We're going to be left with 0, 2, 2, 2. There we go. So this is going to be our minor. Now we move to the next one now. Cofactor 3. Now, when our cofactor is 3, we need to cancel the column and the row where 3 is part of. Now, let's look at our sign. Our sign is going to be negative there. As you can see, our 3 is there. That 3 is positive. So it means now this is going to be negative. Now we write the 3 there. But what is our minor that we're left with here? We are left with 1, 1, 2, 2. There we go. So this is our minor. Now let's do the last one here. Now when you do cofactor negative 3, we also have to cancel the row and the column where negative 3 is. There we go. Now after doing that, now we look at the sign that correlates with our negative 3 there. So it's going to be positive. So you can say positive, but let's not forget that our 3 is negative as well. So our minor that we will be left with is going to be 1, 0, 1, then 2. There we go. So this is what we have for this step. Now when we continue, the next step here, we're going to calculate the determinant of these minors here. Remember, 2 is positive there. So when you calculate the determinant, remember you multiply the first entry with the last entry there, minus by the product of the second entry and the third entry. There we go. And then we go to the next one. We have negative 3 there. Now, when you calculate the determinant of this minor, it's going to be 1 multiplied by 2 minus by the product of the second entry and the third entry. There we go. Now the last one again is going to be positive and negative. That is going to give us negative 3. And then we multiply there. We're going to multiply the first entry, which is 1 multiplied by 2, minus by the second entry with the third entry. There we go. Now when we continue here, so when you put this on a calculator, this is going to give us negative 8. Right. Now let's go to the next one. When you put this on a calculator, this is going to give us negative 0. Let's go to the last one. When you put this on a calculator, that is going to give us negative 6. Now dy is going to be equaling to negative 14, just like dx, guys. So I'm going to write the answer of dy here, which is negative 14 as well. Right, because I'm going to erase this space so that we can do the calculations of dz. Now that we are done with dy, let's calculate the determinant of z. Again, we're going to do exactly what we did when we calculated dx and dy. We're going to substitute the constants here to our third column. Remember, the third column is for z, so that's what we're going to do. So we're going to rewrite our square matrix here for dz. If we rewrite our square matrix for dz, as for the first column, which is for x, it's going to be 2, 1, 1. We don't change it. We keep it from the original square matrix. Same with the second column. It's going to be 1, negative 2, negative 1. As for the third column, we're going to substitute with the constant. It's going to be 3, 0, and 2. There we go. Remember, we are substituting the third column because the third column is for z, and we are calculating the determinant for z. Now that we managed to do the square matrix, it's time for us again to rewrite our cofactor sign. Remember, it's plus, minus, plus, minus, plus, minus, plus, minus, plus. There we go. Guys, the cofactor signs, they alternate. It's time for us to select a row or a column. So I'm going to stick with a row. Also, I'm going to choose the first row because it's easier, guys, when you choose the first row or the first column. Remember, guys, we're going to use the entries that we selected as our reference to calculate our determinant. Cofactor of 2. There we go. So we need to cancel the row and the column where 2 is part of. So I'm going to cancel this column here and that row there. Right, as you can see, we've canceled the row and the column that 2 is part of. So we look at the sign. Let's look at the sign here for the first entry. It's positive, and also that's where 2 is. So it means our 2 is going to be positive. So the minor that we're left with here is going to be negative 2, 0, negative 1, and 2. There we go. Now for the cofactor of 1. Remember, we're moving on this row here. We have to cancel the column and the row where 1 is. There we go. Now 1 is here. As you can look at the cofactor sign, that one correlates with that negative there. So meaning here is going to be negative multiplied by, what is it that we are left with there? Our minor is going to be 1, 0, 1, and 2. There we go. So let's do the last one here. Cofactor 3. Also, we need to cancel the column and the row where 3 is part of. Now, our 3 is here and the sign is going to be positive there. So we're going to write plus there, then 3. So what is it that we have there? Our minor is 1, -2, 1, -1. There we go. The next step now is to calculate the determinant of these minors here, or the square matrix that you see here. So we know that we have 2 here, right? So to calculate the determinant, remember we multiply the first entry with the last entry. In this case, it's going to be -2 multiplied by 2 minus product of the second entry and the third entry, which is 0 multiplied by -1. There we go. Let's do the second one then. Minus, we have 1 here. The determinant here is going to be the multiplication of the first entry and the last entry. Now, the next step here, right, when you put this on your calculator, your answer here is going to be -8. Now, when you go to the second one, you put it on a calculator, your answer here is going to be -2. And the last one here, if you put it on a calculator, your answer here is going to be +3. Your dz here is going to be -7. Now that we managed to calculate our dz, dx, and dy, it's time for us to calculate the actual variable, our x, y, and z. So I'm going to create a space where we can able to calculate them. So here's where we're going to calculate them, guys. Let us not forget that dz is -7. Now, when you calculate the variable, it's as follows. X is going to be x is equal to dx over d. If you still remember, our dx is -14, and our determinant, the first one that we calculated earlier, is -7. So this is going to give us 2. So x is equal to 2. Now, as for y, we do similar thing there. It's going to be dy over d. Now, remember, dy is equal to -14, while our d is -17. So our answer here is also going to be +2. As for our z here, we're going to do with them. We do similar thing there. It's going to be dz divided by d. Now we know that dz is -7 divided by d, which is -7, meaning our z is 1. We know that x is equal to 2, y is also equal to 2, and z is equal to 1. So you'll have to check these answers, whether they're correct or not. So in order for you to check these answers, you need to take one of the equations here from this original equation. Is that you take equation 1, 2, or 3. So I'm going to take equation 1 there. So I'm going to write it underneath here. So it's 2. Wherever there is x, you substitute with x. Remember, x is 2. 2 multiplied by 2 plus y, but our y is also 2, minus 3 z, but our z is 1. There we go. So this here must give us a frame. So we have 2 multiplied by 2, that is going to give us 4, plus 2 minus a frame. So all in all, this is going to give us frame, which is the same as the 3 that you see there. Guys, you can take any equation and substitute there with our x and y and z. Right, I hope this question, guys, was not that difficult. Yes, it was too long, and it required you guys to use the cofactor expansion method and also to know how to calculate your minors. So guys, if it so happened that this video helped you to know how to calculate or learn how to calculate the 3 variables that we have here, you can like, share, comment, and also subscribe to the channel. You can always support our channel by hitting the super thanks button. But if you can't do that, the simple like, comment, and subscription will be highly appreciated. Guys, if it so happened again that you didn't understand, I would recommend that you go back to the point where you got lost, try to rewatch it, and if that doesn't help as well, you can leave a comment on the comment section. I'll try to help you to my level best. Guys, this is how you calculate the variable using the Cramer's rule when you're given 3 by 3 square matrix. Thank you very much, guys, for watching. Till next time, cheers.